Hello? Oh, wow. Hello. Okay. Hi guys, I'm Fawaz Mohsin. I am a biomedical engineer here at UConn. And I'm from Simsbury, Connecticut. Hit me up on Twitter or Instagram if you want.
I'm John Gallagher. I'm also from Simsbury. I'm a civil engineering major. Alright, so our project is about the Game Boy Color, and we're basically going to tell you how it works. So we're going to start off with what is Game Boy Color. It is it's the second Game Boy product released by Nintendo. It came after the original Game Boy. It was released on October 21st, 1998. And Nintendo fans wanted more after the production of the original Game Boy because it was so successful. And so what they got in return was the first backwards compatible handheld gaming system. It was the third best-selling console of all time, and when you compare it with the original Game Boy, it was the first. And the Game Boy Color was the first Game Boy to have full colors. It had 56 colors compared to just 4 shades of gray in the original Game Boy. And in our project, we're going to talk to you about the CPU, RAM, LCD, and then also the sound, speaker, buttons, and potentiometer.
Okay, so the motherboard is what is pictured on the right here. The motherboard contains all the principal components of any computer. At the end of this arrow here, we have a CPU. The CPU is responsible for interpreting and executing commands for the computer. Let's see. The CPU is the brains of the Game Boy. The CPU that's included in the Game Boy Color is an 8-bit Z80 based chip. It interprets the input of the buttons, the info from game cartridges, and the twisting of volume knobs. Clock speed is the number of computations any computer can do in any given second. The clock speed of the Game Boy Color is 8 megahertz, which is 8 million computations per second. This may seem like a lot of computations, but when we look at an iPhone 6S with a clock speed of 1.85 gigahertz, it can do 1.85 billion computations every second. The Game Boy also has 32 kilobytes of random access memory, which we'll talk about more on the next slide. So RAM, what is RAM? RAM is short for random access memory. Let's see. It is the Game Boy's working memory. It provides quick read and write access to data to the Game Boy. And the reason why the Game Boy does this is because it's quicker than loading it sequentially off of a CD or a hard drive. The Snapchat running on our phones, the refreshing of our inboxes, and the updating of weather all happens in the RAM. There's two types of RAM. There's DRAM and SRAM. DRAM is dynamic random access memory. Dynamic random access memory must constantly be refreshed or it will lose its contents. For example, in Pokemon Leaf Green, when you were walking to hatch an egg, the number of steps that you step must always be refreshed in order to see when the correct number of steps has occurred before the egg can hatch. Static random access memory, or SRAM, as you can tell from the name, it does not have to be constantly refreshed in order to keep its contents. This would probably include stuff like the basic rules of the game, such as not being able to walk through water or walk through a wall or something like that. And then there's a third type of RAM, it's actually called ROM, or read-only memory. And as you can tell from the name, the Game Boy can only read this type of data. This would include stuff from like game code from the game developers or something like that. So all this talk about CPUs and RAM has got us thinking, what are the limits of computer speed? Computer speed has been growing exponentially faster and smaller at the exact same time. Gordon Earl Moore, co-founder of Intel, plotted the number of components per chip, that includes transistors, capacitors, and resistors per chip in between 1959 and 1965. After extrapolating his line, he was able to predict that the number of components would double every 2 years. So his prediction turned out to be true, and although it has turned out to be true, clock speed has actually stabilized around the year 2000. And that is because heat dissipation from all the components of a chip are more than the chip can withstand. So at the same time that we're getting faster, we're also getting smaller. single atom transistors exist in our computers today. So we're kind of stuck here. We can't get any faster, we can't get any smaller, and fitting more pieces onto a chip doesn't make it any faster either. So this is where quantum computing comes in. So what is quantum computing? Simply, scientists and mathematicians have used math to prove that matter can exist in two states at the exact same time. So we're engineers. So we're engineers, right? We know what bits are. They group together and they can hold information and have value of 0 or 1. But a qubit, the type of bits that are used in quantum computers, are just like bits, except they're in superposition. They can be any value of 1 or 0 at the exact same time. So they can be any proportion of 1 or 0 at the same time until the instant that it is read. Which is why at the end, when you see it go through like the little refracting thing, it chooses a polarization. So why is this applicable to us? Why do bits in superposition make our computers get faster? So say we have a 4-bit computer. A 4-bit computer can be in any of 2 to the 4th combination or configurations at once. That's 16 configurations of which it can only be in one of. Conversely, looking at 4 qubits, 4 qubits can be in all 16 configurations at the exact same time. This number grows exponentially. It only takes 20 qubits to get to 1 million configurations at once. So a 300-bit computer would power something near like our calculator, but a 300-qubit computer has the power of a 2 followed by 90 zeros worth of bits. So it grows by a lot. Quantum computing is still early, but companies such as Microsoft, Intel, and companies like that are working on the cutting edge of it. So the LCD, short for liquid crystal display. The Game Boy was revolutionary because it was the first backwards compatible and full color gaming console available on the market. It has a reflective LCD, 160 by 144 pixels. This is compared to the original Game Boy, which can only display 4 shades of gray at the exact same time. So what is an LCD screen? To uncover that, we must uncover what a liquid crystal is. Liquid crystals were discovered in 1888 by Friedrich Reinetzer, an Austrian chemist, who found liquid crystals to be something in between a solid and a liquid, almost like oobleck that we make in our labs in like 5th grade. So each pixel in the Game Boy Color's LCD screen has 3 liquid crystals in it. The entire screen is backlit, and electrical current can be sent to each pixel to polarize the 3 crystals to produce any combination of red, green, and blue that we want.
So now we're going to talk about sound. Sound is a pressure wave made of vibrating particles that move through the air, and we call them longitudinal waves because the particles move perpendicularly to the direction of the wave. Sound's measured in decibels, and decibels have a logarithmic relationship with sound intensity, which means if you look at this graph, it tells you that 10 times the power gives only plus 10 decibels. And decibels is not a physical unit, it's only used to show a ratio. This is the equation, 10 log 10 of I divided by I sub O, and I and I sub O would be 2 different sounds at different decibel levels. Here's a common sound chart showing a bunch of common sounds and their decibel levels. So as you can see, a pneumatic drill has a rating of 100 decibels, while a loud rock concert is 110. And that might look like the concert is only a little bit louder, but it's actually 10 times louder. And so the speaker of the Game Boy is shown in the bottom right of this motherboard picture. It's a circle. It has 3 main components to it. It has the cone, the electromagnet, and the magnet. The electromagnet is what does most of the work. It's a metal coil, and it conducts electricity. And while the electricity passes through it, it changes the electric field. And so what that does is it makes it constantly attracted to and repelled to the permanent magnet. So what this does is it makes it vibrate, and this makes the sounds that we hear. And then the cone amplifies the vibrations of the sound, and it pushes the sound waves into the air. And so this is how speakers play all the sounds we hear, because nowadays we're able to change the frequency to adjust the pitch and the amplitude to determine the volume. So that's how we're able to play a wide range of sounds. And then something cool about speakers is that they actually work opposite of microphones. And so microphones work, they're a transducer because they change sound waves into electric current. And that's the exact opposite process of a speaker. And so this explains why if you put a speaker too close to a microphone, you kind of get like a big, loud, annoying noise. And that's because the sound just keeps looping really quickly, because sound is moving at 340 meters per second. So that's why it all of a sudden kind of creates that big, loud, annoying noise you hear. And we wanted to test the range of sound in our Game Boy, so what we did is we used the Decibel 10 app on iPhone, and what we did is we recorded Pokemon Yellow music for 20 seconds, and we started at a medium volume, and then we lowered to the minimum volume of the Game Boy, and then up to the max. We did this to see the range of sound. This is a graph of our results. As you can see, the lowest decibel level was 53.2, and the highest was 74. That gives us an average of 63.6. We thought that was pretty accurate because if you compare it to the common sound chart, that puts it at slightly above the decibel level of normal conversation. And then for the buttons, the way buttons work is they complete an electric circuit using a metal spring, kind of as shown in this diagram. There's two types of buttons. There's momentary contact and non-momentary contact. Momentary contact buttons work only when pressed. Non-momentary contact buttons work when pressed and then once pressed again. So all the buttons on the front of the Game Boy are non-momentary contact, are momentary contact, because they only work when pressed. The only button that is non-momentary contact is the power switch, because you need to press the button and keep the Game Boy on. You don't just need the button to work when you press it, you need it on the whole time, and then you need to turn it off when you're done. And the last part of our Game Boy that we researched is a potentiometer. What it does is it changes the resistance of the volume. And it has three terminals. It has two ends and one wiper. And so the wiper moves and changes the resistance of volume. Farther path is more resistance, and a shorter path is less resistance. There's two types of potentiometers. There's rotary and slider. The Game Boy uses rotary because it's more efficient in the sense that it's a circle, so you can move the wiper more distance as compared to just a line. And so this allows you to get a wider range of sounds and more precision when you're choosing your volume. And that's about it.